Hello and welcome back to the course on automobile engineering. We'll continue our discussion on transmission system. In today's lecture, we're going to look at two gearboxes. Number one is a constant mesh gearbox, followed by Sychromesh gearbox. We're going to look at the constructional features, followed by its operation. Before we take up our discussion on these gearboxes, we'll look at the classification. The types of transmissions are shown here, broad classification. Among these, our focus is on manually operated selective transmission. In the last class, we have studied a sliding mesh gearbox. In today's lecture, we're going to look at constant mesh gearbox, followed by Sychromesh gearbox. So we'll now begin with constant mesh gearbox. So we have an engine on the left side, followed by clutch, and then we have a gearbox here, which is also called as transmission. And then onto the right side we have propeller shaft and so on. And we have 3 forward and 1 reverse gear arrangement in this gearbox mechanism. We'll now look at the constructional features of this constant mesh gearbox. So here we have the clutch shaft. Onto this we have a clutch gear which is mounted, and this clutch gear is in mesh with another big wheel gear which is mounted on the counter shaft. This is also called as a lay shaft. We see that onto this lay shaft we have gear wheels of different diameters. So we'll begin numbering this. The smallest one is gear number 1, followed by 2, 3, and the 4th one. And on the other side we have a splined shaft, and this shaft is called as a main shaft. It is also called as output shaft. On to this main shaft we have again 3 wheels, gears, which are mounted, followed by dog clutches, which we can see, one on the left side, the other one on the right side. And we also notice that we have a black shaded area here for 3 gear wheels. These are the bearings. Therefore we understand that these gear wheels are mounted on the bearings, and the bearings are in turn mounted on the main shaft, and the rotation of these gear wheels are independent of that of main shaft. Further, we see that the dog clutches, they have a tooth on its sides, and they are helpful to mesh with the gears as and when required. Now let us look at the working process. Let us start with first the neutral gear. In the neutral gear, the clutch dogs, they are not in mesh with any of the gear wheels on the main shaft. Thereby we see that the power that is transmitted to the clutch shaft will be transmitted to the lay shaft, and from the lay shaft the power is again transmitted to the gear wheels which are mounted on the main shaft. However, the main shaft is not set into rotation because these gear wheels, they are not firmly attached to the main shaft. They are just revolving over the bearing, and the rotation is independent to that of main shaft. So that is about the neutral gear. So during the first gear operation, let's say that this is gear number 1, and then this is a gear number 2, and what we have here is a reverse gear. So when the clutch dog on my right, when it is in mesh with the first gear, we see that the power that is transmitted from the engine to the clutch shaft will be communicated to the lay shaft. From the lay shaft, gear number 2 will be set in rotation, and this is in mesh with gear number 1 on the main shaft. Further, the rotation of the gear number 1 on the main shaft will transmit power to the clutch dog, and from the clutch dog the power will be transmitted to the main shaft, and the main shaft will set into rotation. So this is how we see the operation of first gear. So this shows clearly how the power is transmitted during the first gear operation. Now let us look at the second gear operation. In the second gear operation, the clutch dog which is on the left side will be brought in mesh with the gear number 2, and then we see that the power that is transmitted from the engine will be transmitted again to the lay shaft. On the lay shaft we have gear number 3 which is in mesh with the gear number 2. We also understand that the clutch dog on the right side is disengaged during the operation of the second gear operation. Now the power that will be transmitted from the gear number 2 to the clutch dog. From the clutch dog it will be transmitted to the main shaft. So let us look at the arrow marks to show how the power is transmitted from the engine end to the top output shaft. So this is a working process of gear 2. Now let us look at gear number 3. In gear number 3, the clutch dog on the left side is directly brought in mesh with the clutch gear. Thereby we see that there is a direct transmission of power from the clutch gear onto the main shaft, and this is treated as the top speed, and the flow of power is shown here through the arrow mark. However, the rest of the wheels, they are also in rotation, but since they are mounted on the bearings and there is no clutch dog being engaged, the right one, with any of these gear wheels, there is no any power transmission from these gear wheels to the main shaft. Now let us look at the operation of reverse gear. In the reverse gear we understand that we have the first gear here on the lay shaft. Immediately after that we have idler gear which helps in reversing the direction of rotation of the gears, followed by we have a reverse gear which is mounted on the bearings. Now during the operation of reverse gear, the clutch dog will be brought in mesh with the reverse gear, while the clutch dog which was earlier in mesh with the clutch shaft will be disengaged. Now with this arrangement we see that the power is transmitted from the engine to the clutch shaft, clutch gear, and then to the wheels of the lay shaft, and then we see that the direction will be reversed through this idler gear, followed by the power will be transmitted from the reverse gear to the clutch dog, and from the clutch dog to the main shaft, and then to the propeller shaft further. So let us look at the power indications through these arrows. We see that this arrow mark indicates the rotation of the clutch gear is in the clockwise direction. Since it is meshed with the another gear wheel on the lay shaft, this will rotate on to anti-clockwise direction, and the same direction will be experienced on the gear 1, since they are all connected commonly firmly to the lay shaft. Because of the presence of idler gear, which we can see here, which we studied in the previous class, the idler gear, which is colored with the green, reverses the direction as shown here. But at any point of time, gear number 1 on the lay shaft is not in direct contact with the reverse gear. So we see the difference here. And because of the presence of idler gear, the direction will be reversed. And then we see that the clockwise rotation of the clutch gear is completely different when it comes to the main shaft rotation. It is in the anti-clockwise direction. Thereby the vehicle is going to back off. So this is about the working process of constant mesh gearbox. Now let us move ahead looking at the next gearbox working process. So here we have the mechanism of Sychromesh gearbox. Here on the left side we have an engine followed by a clutch, and we have a clutch gear which is further connected to a layoff shaft as shown here. And to this layoff shaft we have gear wheels of different diameters, where we have U1, U2, U3 and U4. These are the different gear wheels which are firmly attached to the layoff shaft. Onto the main shaft, we have the main shaft here. Onto the main shaft we have again set of gear wheels which are numbered as B, C, D and E, and these gears are in direct contact with the gears on the lay shaft, which means that the rotation of the lay shaft is going to set in motion the gear wheels which are mounted on the main shaft. Further, we see that there are two Sychromesh devices in this mechanism. The pointer what is showing here is Sychromesh device. We have one here and the other one is shown here. We also see that the diameter of these gears are quite different compared to the diameter of the gear wheel on the other side. So that gives us an idea to us that different gear ratios are possible in order to meet the demand as per the driver's requirement. Now let us look at the working process. When a gear lever is shifted towards the left side, we see that the Sychromesh device will be brought in contact with one of the gear. Let's say that this is gear number 1, that is gear number D, and gear number C as gear number 2, and gear number B as gear number 1. And whereas gear number E, let us treat this as it is a reverse gear in fact. Now during the operation, when the driver shifts the gear lever, he brings the Sychromesh device in contact with that of gear wheel. So we see that there are two tapered surfaces here. So when the Sychromesh device slides towards the left side, then we see that the two tapered surfaces will be brought in perfect contact with each other, and this will establish equal speed, the speed at which the gear wheel D is rotating, the same speed the Sychromesh also will be rotating. Further, if you look at the internal arrangement of Sychromesh device, we see that it's quite clear on the other side. It has again two gear wheels inside. The one which is shaded here is the internal gear. The one which is on the outside here is the external gear. Further, this external gear is in mesh with the splines, and these teeth will be in mesh with the external gear, and these external these splines are again further connected to the main shaft. So when the tapered surfaces are brought in perfect contact, the speed will be in perfect match. At that moment, the internal gear will be sliding over to the tooth as shown here, which is numbered as P1. So thereby we see that the power that is transmitted from the engine will flow across the lay shaft, and from the lay shaft towards the gear wheel which is mounted on the main shaft, and from the main shaft it will flow through the tooth, that is P1. From the P1 the power is going to be transmitted to the Sychromesh device, which is further connected to the main shaft, and then the main shaft will be set into motion. So this becomes quite clear when we look at the arrow marks indicating the nature of power flow. So this is the operation of first gear, and during the operation of second gear, the Sychromesh will be brought back to its initial position. So therefore there is no contact here between the Sychromesh and gear D. And now let us look at the gear C, which is gear number 2 for us. In this case, when the Sychromesh will be slided towards the right side, again we see the two tapered surfaces will be brought in contact with each other. So this ensures the same constant speed will be transmitted from the gear wheel to that of Sychromesh. Thereby the Sychromesh will be set into motion, which further going to rotate the main shaft, and that will happen only when the internal gear, which is on the top of the Sychromesh device, when it is brought in mesh with the tooth on the N1. So thereby we see how the power is transmitted from the engine to the main shaft. Let us look at the power flow through these arrows. We can see how the power is flowing from the engine to the lay shaft, from the lay shaft to the gear C, that is gear number 2, and from the gear number 2 through the tooth gear wheel, it is further brought in contact with the Sychromesh device, and towards the main shaft we can see how the power is flowing. Likewise, again bringing the Sychromesh device in contact with the gear number B, we see that the power will flow from the engine to the lay shaft, from the lay shaft to the gear B, from the gear B to the tooth H1, and then to the Sychromesh device, followed by the power transmission to the main shaft. That will be the gear number 3. And we also have reverse gear, and we are quite familiar now in the reverse gear operation. We have idler gear, which helps in changing the direction of rotation of the wheels. Thereby we see that during this operation the Sychromesh device will be brought in contact with the gear E, that is a reverse gear wheel, and thereby by sliding the internal gear which is on the Sychromesh device will set the gear wheel into rotation. However, when we look at the power flow, we see that power is going to flow from the clutch gear to that of lay shaft. From the lay shaft, the direction will be reversed because of the presence of the idler gear, has been briefed in the earlier slide. And then the the direction of the gear wheel of E will be set opposite to that of the clutch shaft direction of rotation. Thereby we see that a reverse rotation is being observed. This sets the vehicle into backward direction, and this is the popular gearbox which is employed in the automobiles, because it is free from noisy operation, and also because of the tapered surfaces and the presence of Sychromesh devices in between the gears. The speed match between the gears and the Sychromesh device is optimum. So this is about Sychromesh gearbox operation. With this we have come to the end of today's lecture. Thank you for your attention.